first session of today, the session 3, and we have Professor Mavroeidis who will be presenting the paper in the session titled Testing the Effectiveness of Unconventional Monetary Policy in Japan and the United States. Professor Mavroeidis.
Well, first I would like to thank the organizers for giving me the opportunity to present this work here today. I will try to save the credibility of the organizers by speaking a bit faster so that we can finish on time. So let me start with a couple of very familiar pictures. Right? So short-term interest rates have arguably been the main or the primary monetary policy instrument in Japan and the United States. As long as we know, they have recently reached a lower bound, an effective lower bound, which poses challenges for modeling them with something akin to a linear vector autoregression, a structural vector autoregression. And at the same time, the flip side of interest rates hitting a lower bound is the emergence of unconventional monetary policy in the form of forward guidance or quantitative easing, which led to an explosion of the central bank's asset holdings. So this paper addresses two main challenges for monetary policy. First, we would like to ask, does the ELB change the response of the economy to shocks? And does it hamper the effectiveness of monetary policy? Now, some people have argued that it does not. In particular, that unconventional monetary policy is so effective that the economy behaves exactly the same way at the effective lower bound than above it. And so the ELB is empirically irrelevant, a term coined by De Bortoli, Galli, and Gampetti in a recent paper. In a similar vein, Swanson and Williams tested or evaluated the irrelevance hypothesis by looking at the change of or possible attenuation of impulse responses at the effective lower bound. So unfortunately, we test those hypotheses. I mean, part of the objective of this paper is to formalize and test those hypotheses, and unfortunately, we reject them, which prompts the second question: how effective is unconventional monetary policy at the ELB? So, to address those questions, we have to deal with two challenges. One is a theoretical one, and the other one is a practical one. The theoretical requires formalizing the idea of irrelevance by asking, is there an economic model that can explain how the ELB can be irrelevant, how unconventional monetary policy can be fully effective. So we do that by developing a simple new Keynesian DSG model with quantitative easing and forward guidance. And on the empirical side, we use a structural model that is a nonlinear VAR and so is capable of dealing with the ELB constraint so that the policy rates cannot fall behind the lower bound. Right, so let me start with a little bit of macroeconometrics 101. When in macroeconomics we want to assess the causal effect of some policy variable X on some outcomes Y, we typically use a vector autoregression. So we take a vector of variables Y and X, we put them together in a vector, and we postulate and estimate a simultaneous equations model, dynamic simultaneous equations model, which is linear in the variables and the coefficients AJ here, and the causal effects of any shock, in particular the monetary policy shock, can be obtained from the impulse response function, which is a function of the coefficients AJ. Now, unfortunately, a linear structural VAR cannot handle occasionally binding constraints. And this is not an issue that can be dealt with using structural change or exogenous Markov switching, because this is fundamentally an endogenous regime switching problem. So we need a different methodological framework. So the ELB, from a modeling perspective, is a pain. But it can also be an opportunity to learn about the causal effects of policy, as I argued in an earlier paper. So let's see how we can deal with it, how we can modify a VAR in order to deal with occasionally binding constraints. So starting from the linear model here, we can take every linear term in the VAR and turn it into a piecewise linear term. How? By allowing the coefficients on the variable that is determining the switch in the regime to change, depending on which regime the variable falls in. So think of the regime being determined by the sign of a variable x. We will have different coefficients, and I color-coded that for your convenience. I have blue for positive regime and red for negative. No political pun intended here. So we can write a general model which involves some kink when the variable crosses the threshold. And if the variable, when it lies in the negative regime, is partially observed, is unobserved rather, it also involves censoring. Hence, I called that the censored and kinked structural VAR in my earlier work. Now, Aruba, Sophocles, and co-authors came up with also a restricted version of that model. They called it a VAR with occasionally binding constraints. Importantly, this model accommodates two endogenously switching regimes, which is what we need in order to handle this data. Right. So, first, let us start by evaluating the irrelevance hypothesis. And to do that, we need to first formulate it. So the irrelevance hypothesis says that there is no change across ELB regimes. And there are two ways of testing it, or we use two ways of testing it here, two sets of testable implications. First, we can test it using an observed policy indicator that is not subject to an occasionally binding constraint, such as longer-term interest rates. And the second approach is to use an unobserved policy indicator, such as the shadow rate. Now, the first approach was motivated by reading of the early literature on the empirical literature during the great financial crisis, where many authors try to get away with a linear VAR by arguing that they can identify the effects of monetary policy using longer-term interest rates, such as 2-year rates or longer, which were not subject to a lower bound. That's certainly the case for the paper by Gertler and Karadi. Right, so suppose now, let's take that view, suppose that the policy instrument is some long rate, call it ITL. And we can estimate a VAR using YTL, YT, and ITL as the variables in the model. That's at least the practice. But then we can test the irrelevance hypothesis simply by adding short-term interest rates in that VAR and testing that they can be excluded. So basically testing the exclusion or the irrelevance of short rates. And that can be very easily done if we embed this model that is our favorite model here into a model that includes interest rates and testing that the coefficients of the interest rate in the equations for the first variable, the y1, can be set equal to 0. Right? So that's an extremely easy test. If that is the case, then the monetary policy shock can be obtained or spanned only by the innovations of the variables that are unconstrained, and we can have linear impulse responses, which are completely unaffected by the effective lower bound. Now, the important thing is that this testable implication can be tested using reduced form. So we don't need any identifying assumptions to get evidence on this. The second approach is slightly more complicated because it involves shadow rates, and shadow rates are not observed, so we need to do something about them in the empirical analysis. Let's assume that the policy indicator is IT, and when it is above 0, we call it IT plus, or above the lower bound, then it is the actual interest rate that we observe, conventional policy. When it is below 0, it is the shadow rate, which we will show later is a measure of unconventional policy. So now let's take our previous variables that are unconstrained, the y1, and write down a VAR that involves also y2, which is the policy rate, the policy instrument, sorry. Right? And in this time, allow the coefficients on the policy instrument to change across regimes, like we said the general model should do. The hypothesis of irrelevance is that a linear model fits this data. That is, the coefficients, the blue coefficients are the same as the red. That's a simple set of linear restrictions on a VAR, so that the linear censored VAR can fit the data. And if we have a linear censored VAR, then impulse responses will be linear, the effective lower bound will be empirically irrelevant. Again, this is something that we can test in reduced form. We don't need to know the A's. We just need to know the reduced form VAR coefficients, and there are no changes across regimes. Now, a brief word on the attenuation effect. If the effective lower bound matters, then the response of long yields to shocks can change. Right? And in particular, Swanson and Williams argue that it will be attenuated. So they tested this hypothesis using time-varying impulse responses with data up to 2012, and they didn't find significant changes. However, the attenuation effect is state-dependent, not time-dependent. It depends on how close interest rates are at the ELB. And it will get worse the further away we are from the ELB in the negative side. And this can be parsimoniously captured by the CKS-VAR model that I introduced earlier. And so we can test it with more power because of the parsimony. And in fact, we can test that there is no change in the dynamics of the yields across regimes. Again, this can be tested in reduced form, and it is a weaker restriction than the irrelevance hypothesis. And as we will show later, we have some concerns as to whether it is equivalent to irrelevance. Right. So, I mentioned two challenges, a theoretical challenge and a practical one. The theoretical challenge is, can we find a model, an economic model, that can explain how the ELB can be empirically irrelevant, how unconventional policy can be fully effective, and can we theoretically justify using the CKS-VAR model that I introduced earlier to analyze the effectiveness of unconventional policy. The practical challenge is that the current methods for doing that, including the one that I introduced earlier, to estimate the CKS-VAR with shadow rates, rely on simulation, so particle filtering, so they can be computationally expensive and inaccurate. But there is a solution to that, so I will mention that later. Right, so first let's talk about the theoretical model. This is a three-equation New Keynesian model that involves inflation, output gap, and interest rates, short and long. And of course, there's an IS curve, a Phillips curve, and obviously a Taylor rule. It involves also bond market segregation. So there are two types of households, unrestricted households that can borrow both types of assets, and restricted households that can only borrow long-term debt. And there are two types of forward guidance implemented via suitable modifications of the Taylor rule. It was one of the rules that Professor Taylor mentioned yesterday, the one that had a Z term in it from the Fed. These forward guidance rules are due to Reif, Schneider, and Williams, and De Bortoli, Galli, and Gambetti. Now we will show in the model that both types of unconventional monetary policy can be captured by a shadow rate. Right, so I don't have time to go through the equations. I will give you a picture for the model. There's a central bank that can set interest rates and purchase long-term bonds. There are two types of households, as I said, the restricted and the unrestricted households. The segregation creates a term premium that can be directly influenced by asset purchases, can be reduced. And of course, households own firms that are subject to price rigidity, and there's a Phillips curve. Right, so that's the model in a nutshell. So let's see what theoretical conclusions we draw from the model. We draw two main results. The first one has two parts. The first one is about what happens under irrelevance. So first of all, the model can explain irrelevance. So we can calibrate unconventional monetary policy to achieve exactly the same effects as conventional policy. And in that case, it can be shown from the model that we can identify the effects, the impulse responses to monetary policy shocks, from a VAR that includes inflation, output gap, and short-term or shadow rates when they're negative. So no long-term interest rates are needed. Now, if in addition the fraction of unconstrained households is negligible, then monetary policy can also be captured by a structural VAR that excludes short-term interest rates, so it only has inflation, output gap, and long rates. In which case we can do what some of the early literature did, and justify what they did. But notice the important qualifier, if the unconstrained households are negligible, if they're not there. Why? And that's a very important insight that we drew from this model. For monetary policy to be as effective at the ELB as it is above the ELB, it has to work harder on the constrained households, on the long yields, in order to achieve the same aggregate effect. So in fact, if there are, in a probably more realistic scenario, if there are agents in the economy that can also invest in short-term debt, then we should expect amplification of the yields at the ELB in order to achieve irrelevance. No attenuation is not enough. Right. So the second theoretical result from the model is that we can microfound the CKS-VAR model the empirical model that I introduced earlier. So in fact, we can show that there is a scalar parameter xi that can be used to characterize the effectiveness of the relative effectiveness of unconventional relative to conventional policy. Unfortunately, this combines both forward guidance and QE, so we cannot separately identify the two effects. But when xi is equal to 1, this is the limiting case that our conventional policy is fully effective, so the irrelevance hypothesis holds. And when xi is less than 1, then the model is theoretically intractable, but with some mild tricks, some mild deviation from rationality that is not dissimilar to other approaches in the literature, like Ockbin. We can derive a piecewise linear structural VAR specification, which is exactly a special case of the CKS-VAR. Right, that involves inflation, output gap, and shadow rates, and it has kinks. Right, so that's how we microfound our empirical strategy. Now, a brief word on identification. The relevance and no attenuation hypothesis can be tested directly from reduced form. So no identification assumptions are needed in that, which is very good. And rejection of the irrelevance hypothesis implies that IRFs under any identification scheme must differ across regimes, right? But if irrelevance hypothesis is rejected, then we need to assess how important it is, how effective it is. And in fact, it turns out that the ELB can help because it generates a change in dynamics across regimes, and that change is attributable to the ELB, right? So that has some information about the relative effectiveness of conventional versus unconventional policy. This is something that I showed in an earlier paper in Econometrica in 2021. So let me briefly explain the intuition for that using a very simplified version of the model. Now, this is a really toy example. So we have two variables. The inflation is the target variable, and I is the policy instrument. Following a Taylor rule, the inflation by a combination of the IS and the Phillips curve can reduce to this linear expression, or piecewise linear expression here, where there's a conventional policy channel with a coefficient beta. That's the marginal effect of conventional policy shocks to inflation. And xi is the parameter that governs the relative effectiveness of conventional to unconventional policy. Now, we can easily solve that model under both regimes. And if xi is different from 1, we see that the decision rules differ across regimes. And this variation gives us one extra piece of information. So in this case, it's just a change in the variance, like identification via heteroscedasticity, but because the change is endogenous, we can't just use the standard arguments. Right. This can even accommodate policy reversals, as Marcus is here, although we have assumed it away in our sign restrictions, unfortunately. Right. So let me now turn to the empirical results. Right, and there will be two sets of results. First, let me go to test of the irrelevance hypothesis, starting with the exclusion of short rates. That's the simplest possible test that we can do. Right, so here is a table where I've estimated a reduced form VARs for the US and Japan that include inflation, output gap, long-term interest rates, 10 years in the case of the US, 9 years in the case of Japan, and short-term interest rates, the federal funds and the core rate. And you see in red highlighted, so there are various models that are being estimated with different lags. In red, I highlight the model that is selected with the information criteria. What you need to focus on is the last column, which is the p-value of the null hypothesis that the ELB is irrelevant. And this is overwhelmingly rejected. Now, we've done this in many other VARs. We've had several robustness checks with different variables in the model. All the time, we get zeros in the irrelevance hypothesis test. So the message is you cannot get away with excluding short-term interest rates from a VAR that pertains to answer questions about monetary policy. Right. So the second approach was using the shadow rate. Can we model monetary policy via shadow rate that is linear, right? A VAR that is linear? And in this case, I show you only the selected results, not all of them. Again, you can focus on the p-values here, which are both small. So we overwhelmingly, again, reject the null hypothesis of linearity. Right? So inflation, yes. Right, so finally, a very brief comment on the no attenuation effect. I promised a more parsimonious test of that effect. We've done several at different maturity levels. In all cases, we reject no attenuation. Of course, this is a two-sided test, so we're not testing against the alternative of attenuation. It could be amplification. But the important thing is that the no attenuation hypothesis is rejected. Right, so now let me turn to the more contentious part of the empirical analysis. The first part was based on reduced form. There's no identifying assumptions, very little to argue about this. The second one is where we need to start using some identifying assumptions in order to identify the causal effects of unconventional policy. Now, before doing that, as a curiosity, we started by asking, can we bring it down to a three-variable VAR, like the most rudimentary model, with inflation, output gap, and short-term interest rates, like the one that we are taught in macroeconometrics from Stock and Watson. Right? That means, can we exclude long yields from the model? So instead of the irrelevance of short-term interest rates, can we exclude the long-term interest rates? And we tested that, and it turns out we can, because we don't reject the hypothesis that the long-term interest rates can be excluded. So now we're going to do our analysis on the impulse responses by using a three-variable VAR in inflation, output gap, and short-term interest rate, or shadow rate, with additional sign restrictions. And the sign restrictions here, that's why they will rule out policy reversal, are borrowed from the Bortoli, Galli, and Gambetti that say a negative monetary policy shock cannot decrease inflation and output gap and cannot increase nominal interest rates or shadow rates within the first 4 quarters. Right. So now you have to understand that impulse responses are nonlinear and state dependent, so they change over time. Right? And they change as we approach, as we get closer to the ELB. So I'm going to present 2 snapshots, 2 state-dependent impulse responses, one in a period where we were firmly away from the lower bound. For the US, that is 1999 quarter 1, and one where we're firmly inside the ELB regime in 2009 quarter 1. If you look at the impulse responses, you notice, if you look closely, that the impact effect of a 25 basis point reduction in the interest rate or the shadow rate raises inflation more in conventional times than in unconventional times on impact, and the same for output gap, but the effect further out is reversed. So it's a bit stronger under unconventional policy than conventional policy. There's not much difference in the output gap, but certainly in inflation. Right? But let me not linger on US because we're in Japan, so we want to focus on the Japanese results. Right, so here are the pictures for Japan. Now the main difference is that we had to go all the way back to 1990 to be outside the ELB regime, because already we were there in 99, very close to it. But before discussing this, let me take the opportunity to mention this computational challenge that I mentioned earlier. Now, these results here are based on particle filtering, so simulations to integrate out the shadow rate when it's not observed. And particle filtering has a known problem of degeneracy, especially which gets worse the longer the period you stay at the lower bound. And that will cause the likelihood to be imprecise and the results, the estimation results, to be noisy. Now, fortunately, I'll take the opportunity to advertise a recent breakthrough that enables me to evaluate the likelihood analytically. So no degeneracy whatsoever. And I will show you the results of the analytical computation, which are, fortunately, qualitatively exactly the same as the simulation results, but smoother. So let's study those results here. Again, we see that the unconventional policy is much more subdued on impact. And in fact, the difference is much starker than in the US. Remember the parameter Xi that I mentioned at the beginning, measuring the relative effectiveness of conventional to unconventional to conventional policy. For the US, it comes out to around 0.75. For Japan, it's between 0.01 and 0.28, so a lot smaller. So a lot more constraint on impact, but unlike the US, it has much stronger delayed effect. So the impulse responses get a lot steeper, a lot higher 1 and 2 years out. Right, so unconventional monetary policy has had smaller effects on impact, but strong delayed effects. So let me quickly summarize what are the two main takeaways from the paper. The effective lower bound has been empirically relevant both in Japan and in the United States. And relative to unconventional policy, unconventional policy has been less effective on impact, but has had strong delayed effects 1 and 2 years out. Of course, this research is only the beginning, and there's a lot more that can be done to refine it. So we have I list here a few priorities that we have in our current research. But the main lesson, if you are to take one lesson from this analysis, is that a linear model is inadequate to model the monetary policy in these two countries. So if you see papers using linear VARs or local projections for that matter, be very skeptical. Thank you.
Thank you very much. And the discussant is Dr. Segendorf.
Yes, hello, and many thanks for the kind invitation to this conference. It has been a great pleasure during these days, and I will bring home a lot of new knowledge. So I'm going to comment on this paper, and I just want to have the usual disclaimer there. So what is this paper about? So as you've seen, when the ELB has been hit, how effective has unconventional monetary policy been? And this is what it's all about. And this was shown very nicely by Sophocles just now. So the question is it as effective as an ordinary short-term interest rate policy, or is it less effective? And the authors develops a theoretical model that allows for both possibilities, and then they conduct empirical tests. And the idea is that if macroeconomic variables behaves the same more or less, and the dynamics and volatilities are the same, then it doesn't matter which tools you use. And they show that the results that the irrelevance hypothesis cannot be rejected, or can be rejected, sorry. And there are also delayed effect of an unconventional monetary policy. So I think overall this is a very important paper. And also the main takeaways would be that it's excellent, it's innovative, and very interesting. And it's also very relevant for practical monetary policy. And the reasons for that are, of course, that inflation may be very low in the near future in many countries. So to discuss the effective lower bound is always relevant. And it is also clever to study the relevance of the effective lower bound and the effectiveness of unconventional monetary policy at the same time. So it's very innovative and clever. So I will go through some big questions about the paper, not going into the details. So one big question is, are the effects of unconventional monetary policy the same depending on the purpose for doing unconventional monetary policy? The theoretical model in this paper allows for the degrees of effectiveness of unconventional monetary policy to range between being as effective as unconventional monetary policy to being completely ineffective. And it provides a theoretical underpinning to this. And this is very fine and excellent. But what if, depending on the purpose, in times of financial stress, there is actually the case that in a credit easing situation, that conventional monetary policy is more effective than conventional monetary policy. One general conclusion of unconventional monetary policy is that it has been especially efficient tool during times of financial stress and to dampen premium on risky assets. So that is one question that it would be nice to discuss. Another question is, could it also vary depending on duration on bonds bought? Like in the paper, the central banks have only bought long-term bonds. But even short repo rate has been affected, and we show that in the case for Sweden. How would allowing for buying a broader spectrum of assets affect the results? And also, the effective lower bound could be very varied where it is. It's very hard to be sure exactly the level of it. So sometimes it would be better just to decrease actually the interest rate instead of buying bonds. And in the future, it would be very interesting to study effects of a soft or uncertain lower bound in this model. And this is really a very common feature of many lower bound studies or discussions, that it is uncertain and not fixed and given. And as I'm from Sweden, a small open economy, like previous governor to us said, we are a small boat on a big sea. Are the effects the same for small open economies as they are for large economies? In this paper, small open economies aspects are ignored, which is natural because it studies large economies, but it's an interesting question. So the question, would additional channels change the results in this paper? If you were to add open economy aspect channels to the model, could it like sharpen the inference? And there are factors that speaks for that effects may differ between small open economies compared to large economies. Foremost because of the effect of the exchange rate, of course. But like for Sweden, other effects could also be at hand. Also that the Swedish financial sector and system is closely integrated with other countries and with the rest of the world. And also now the special case for Sweden is that we have a very, very low governmental debt. compared to other countries. On the other hand, we have a very, very high household debt, and we have a very low fixed interest rate on the loans. So we are very sensitive to changes in interest rates. So that would be very interesting to know more about. And just to know, everyone is not familiar with Sweden, but we are in the EU, but not in the euro cooperations. We have an independent monetary policy. Okay, so that was some big questions. Some assumption that would be nice to have to clarify is, for example, how much asset does the central bank need to buy in the paper of the share of outstanding stock to affect the shadow rate as much as conventional policy? It's hard to grasp, or I didn't get it from the paper. Should we buy? And like Marcus was talking a little bit about that. And also, what are the effects on purchases on long-term bond yields, inflation and output in the empirical analysis? That would be more interesting to discuss more. And for more specific, there is this paper, 50 Shades of QE. That is the question in that paper is actually if central bank studies give more positive effect of QE than other academic studies. But as a by result, they get the meta study of results and how is this result in comparison to that paper. And to look at the attenuation effect, there is an example from Sweden. And it related to the state-dependent nature of the transmission in and out of the effective lower bound. And this is a simple test of the effectiveness according to this paper seems to be state-dependent. And like you said, long-term yields should react different during effective lower bound. And this is something we also find in the Swedish case. And there does not seem to be attenuation in the response of long-term rates to monetary announcements. So this is a picture of a test. The figure shows regression of interest rate of different maturities in a particular lower bound period, 2015, when we lowered the interest rate to below 0 in Sweden, and the whole period, including then the 2015-2019 in the red. And we note that the response of the long-term yields were significantly larger during the effective lower bound period. So I have some suggestions for future research. So the first, as I told you, open economy aspects that would be really nice to know more about. Also, could it be possible to distinguish a effect in normal times compared to times of financial stress, and if that is more effective than conventional monetary policy? And the third one is the fiscal impacts of conventional monetary policy. This is going to be a lively debate. It is a lively debate in Sweden, and it's going to be a lively debate for a long time to come. Conventional monetary policy rate cuts has quite easily effects. They higher GDP and they lower interest rate expenses for the government. But as UMP decrease or has an effect on losses for the central bank, it will also affect the government. So that would be nice to have more, if possible, in the paper. But overall, this is important results for practical monetary policy, that unconventional monetary policy has strong delayed effect. And you cannot only study unconventional monetary policy by looking at event studies. So you need more clever and innovative identification and modeling, as in this paper. So thank you.
Okay, thank you very much. And in the interest of time, let me take some questions before I let you respond. Again, you can raise your nameplate. Okay. Professor Reich.
Three comments or questions. First, on this question on the long run and the short run, Sophocles, I think your description of the theory, but the way you've implemented, don't quite match up in the following sense. The points of Swanson, Williams, De Bertoli, and Gali is that a 2-year rate is often an indicator for monetary policy, and that would never hit the zero lower bound. And as a result, there's been no change because the 2-year rate was always a constraint. That would be the long rate in their arguments. But then your empirical implementation used the 10-year rate as the long rate. And so that's a bit of a disconnect. So their point is that if you use the 2-year rate, that would exclude the short run rate, that would exclude, say, the policy rate, and with the 2-year rate, things would be unchanged, whereas you do with a 10-year rate. And so that's a big difference, actually. And this goes back to an old Fed wisdom that the 2-year rate is a better indicator than the federal funds rate for monetary policy. That's the point there. Not that the 10-year rate is better than the 2-year rate. So there's a point. Second comment or question is, so just because 3 former students of mine, Wataru Miyamoto, Dmitry Sergeyev, and Lan, they have 2 very nice papers that look with either oil shocks or fiscal shocks with Japanese data at the ELB or without. You get very different responses in one and out. So they're a nice complement to your monetary shocks. But the point that they seem to find strongly in their VARs is that what's crucial is whether you put an expected inflation series. Because going back to the models of the ELB, it's the fact that shocks, whether oil or fiscal in their cases, or in your case monetary, they shift expected inflation much more at the ELB than not. That is the mechanism through which, as very well nicely put in Krugman's original ELB paper 30 years ago, that would drive. So I would really wonder whether you could include an expected inflation. I think that would be a wonderful illustration of whether the VAR coefficients change on that. And finally, third, I mean, there's an identification challenge that I wanted to talk about a little bit in this context. The identification challenge of many ELB papers, as well as this, is that it's not that we hit the ELB some quarters and not some others, and so by distinguishing them we identify, is that we were at the ELB for a series of years in Japan, and then some other years we weren't in the sample. And so so there's really two regimes, if you want, but then anything that's different across those regimes will make it very difficult to identify if it's the ELB or something else. So concretely, in Japan, during the times that they were at the ELB, it was also times at which you may think, well, there was just different things in the economy during those times versus the others. So how do you think about identification of just separating ELB versus either the shocks that caused the ELB to mine, maybe it's a lower star, maybe it's something else, but how do you think about those within the context of yours? Because it seems like your methodology allows some progress on this insofar as because it's about the censoring, not about the fact that during these times there's 50 other things that are different. Thank you.
Professor Mavroeidis.
Thank you. First, I'd like to echo the discussion. I think it's very important to do this work, and it's very nice to see a way of trying to see to what extent the unconventional policies are different, but still have traction. So the 2 questions I have are about regime shifts and empirical robustness. So on the regime shifts, the question is, in your empirical methodology, are you able to accommodate situations where the central bank's reaction function may be shifting? We've heard yesterday from, like Olli mentioned, for example, in one of the episodes we had with the pandemic, you have a new shock, and then you're trying to figure out how to respond to this, which is by definition and description of a shift in the policy reaction function for a while before you go back to something that would be a more normal reaction function. So that's one question. The other question, I see that in the empirical analysis, you are relying on output gap measures, and for the US, for example, you are taking the CBO's output gap measure, but that actually does create the problem of what's in the reaction function, given that the output gaps that you are using as data are not data. They actually have a lot of measurement error. The real-time renditions of the CBO's output gap, even just for the last 15 years, have very serially correlated discrepancies relative to the ones that you are using, coming from the fact of what Marcus was showing this morning. You have this shift after the global financial crisis. If you check the CBO numbers, it took the CBO about 10 years to allocate the potential output revision. About 60% was closed by revising the potential output, not demand, not catching up element, which actually totally changes the time series that you are using for the output gap. So I wonder to what extent you are able to accommodate for serially correlated measurement errors in this when you are showing us the p statistics that are so incredibly small.
Deputy Governor Uchida.
Thank you, and thank you for the very interesting study. Well, I have just one question about the effectiveness of unconventional monetary policy. One of your takeaways is that the unconventional monetary policy is less effective, but then hold longer impact on the economy and prices. I wonder what the underlying mechanism on this kind of effect. It is quite natural that the QE is slow to have effect on the economy because it's basically rely on the stock effects. But then your study basically rely on the based on the new Keynesian model, so it is not just financial thing, it is rather than the real side of the economy. So I wonder what kind of mechanism is underlying your takeaways. That's my question.
Okay, let's pause here and ask Professor Mavroeidis to respond, and you can respond to discuss and comment as well.
Huh? Okay. Well, first of all, thank you also for this very complimentary discussion. It's really kind of you. You've raised a lot of very pertinent points, and I don't know really what to start with. Can we? Well, let me list them. So, does the purpose of unconventional policy matter for the analysis? Well, it can, right? So here we took the view that the objective is price stability, so we evaluated the effectiveness of unconventional policy with the same objective in mind as conventional policy, but certainly it can. And if your question was about whether we can also allow for unconventional policy at times when we are above the ELB, yes, we can. And the methodology can adapt to that. So we can also model having QE when interest rates are above zero. We haven't done that in this paper because we didn't feel it was relevant for the sample that we analyzed, but it certainly can be done. And that is only affecting the second part of the analysis, not the test of the irrelevancy hypothesis. For that, by the way, we did test with the 2-year rates, and again we reject. So we've tested this 6 ways to Sunday, and every time we get zeros in the p-values. So that's why we're very confident about this part of the analysis. Now, does the maturity of the bonds or the type of bonds matter? It could. And in principle, we know that there have been many different phases of QE, unconventional policy, even in Japan. So the different episodes were characterized by different types of quantitative easing. And in principle, that can be reflected in a different degree of effectiveness. In our causal analysis, we assumed the coefficients are constant across the different types of QE. So we had an unconventional and unconventional regime. But in principle, we can allow time variation in the parameters, and we can also accommodate. That was one of on the to-do list. We can allow variation. As policymakers get better at this, maybe the effectiveness increases over time, and that can be accommodated. The uncertainty at the effective lower bound, whether it is a soft lower bound, that's also a very important question. So we've taken a very sort of rough approach of fixing the ELB, as Hayashi and Koide did for Japan, as some additive number to the interest on reserves. But that can be modified, of course, but it's a little bit more challenging because we need to deal with the uncertainty in the empirical analysis. For small open economies, I will leave this to people like you to deal with, since you work in a small open economy. So I have no expertise in that. But the methodology can accommodate having other features, such as exchange rates or other features of small open economies. How does QE affect the shadow rate and the connection to the 50 Shades of QE paper? Well, in that paper, they almost did a meta-analysis, and thanks for introducing me to that paper, by the way, where they looked at different papers and they compared them in terms of the impact of a 1% of GDP magnitude QE. So how were they estimating it in different studies? Now the problem here is we cannot separately identify QE from forward guidance. And forward guidance can affect the level of the shadow rate. So if we could, and we have some thoughts about that, then we could regress our shadow rate on measures of asset purchases, and we can find the coefficient that will convert, shadow rates to levels of QE. And then we can do this analysis that you want. But at the moment, we cannot distinguish between the two. So that's the only obstacle at the moment. So that's why we cannot put the results in context of the 50 Shades of QE paper. I really like the amplification effect that we showed us for Sweden, because that speaks to our argument that you need the amplification for QE to be effective. So that was really cool. And on the fiscal impact of unconventional policy, we can extend the VAR by adding fiscal measures like that GDP ratio and see what happens as well. Now let me turn to the questions from the audience. So Ricardo's first question I already answered. The suggestion to add expected inflation is an excellent one, and we'll certainly do this, because we estimated about 200 different VARs or more with the robustness checks that we were asked to do. But adding expected inflation wasn't one of them, so we can certainly do that. And on the identification challenge, yes, of course, there could be other things that change over time. And at the moment, we compared regime switch against a stable model, a linear model, because the literature that we were confronting is one that assumes a linear model, like the Gerler and Corradi paper, for instance, and other prominent papers. So the conclusion is you cannot have a linear stable model over time. And you can explain the variations in the data by allowing endogenous regime switching through the ZLB regime. But you can also add other time variation. You can combine. That will, of course, dilute the information, so you will lose some of the identification. You can't use the ELB for identification, as I suggested in my earlier paper, if you have too many things changing. But you can still use other identifying restrictions, like conventional, standard, or external instruments. So this is in principle possible. So we think of this more of a methodological framework rather than the final word on unconventional monetary policy in the US and Japan, obviously. Athanasius' paper questions, the regime shifts, can we accommodate shifts in the reaction function? Yes, we can, and we have explored that in some subsequent work. Especially in the COVID period, we need to allow for a different regime. And of course, the easiest way to do this is to dummy it out, but you can also have more creative ways, but it's certainly possible. And I was very pleased to see that you raised the question that I would normally raise to macro people about output gap and the measurement error involved in using output gap in studies. Now, this is not, if I put my econometrician's hat, using output gap is not kosher because of the unmodeled measurement error, which will affect the results, and especially the measures of sampling uncertainty. So the ideal approach would be to, instead of take external measures of output gap, to model it using some latent process for potential output. And now we have the technology to do that as well. Now, when we wrote that paper, we didn't, but now we can. So that is, I'm pleased to say, that's another breakthrough that we had in the methodology. So we can certainly address that concern. And the final question is, what is the underlying mechanism that can explain the delayed effects of UMP? We're quite silent on this. Now, the theoretical model is too restrictive, and it's basically a toy example to show that this can be formalized. In fact, in the theoretical model, it is so restrictive that QE cannot have stronger delayed effects than impact effects. The parameter xi, which measures the relative effectiveness, forces it to be the same across horizons. So in the empirical analysis, we didn't need to impose the restrictions of the theoretical model. That's why it's more agnostic. And of course, we can allow for delayed effects, but we have yet to think about mechanisms to justify them. It could be that there was a change in the reaction function during the ELB regime that made it more persistent, or it could be that there are other factors that we haven't thought about yet. So that's certainly an important question for future research. And one final thing that I think I missed from Åsa's comments was about another regime. So currently we have two regimes, but maybe there are different regimes. There's times, normal times and times of financial stress. So can we have a 4-regime model or 8-regime model? Yes, we can. Again, this is something that we have generalized the methodology, and now we can accommodate multiple regimes, and we can extend our analysis. Thank you.
Thank you. Since I started 10 minutes late, can we take 10 minutes or so? Okay. Let's take a quick second round of questions. Professor Shioji?
Yes, thank you. 2 questions. First, do you worry about the lower bound for the long rates? I can see why you didn't want to use the 2-year rate for Japan, but even the 10-year bond rate was at some point negative for a prolonged period. So that might have some impact on your results. So that's question number 1. Question number 2, can you use the same model for the Japanese QQE period when the policy target was quantity versus during the YCC period when the central bank basically set the target for the long-term yields? So those are 2 questions. Thank you.
Professor Shintani?
Thank you. I think it's a great piece of work. And in a standard linear VAR model, impulse response function is proportional to the size of shock, and shape doesn't depend on the size. But in a nonlinear VAR model, like the one you proposed, sensor and kinked VAR model, the shape of impulse response function depends on the size of shock as well as the history, the past history. And looking back at unconventional monetary policy period in Japan, there were 3 episodes that brought a big surprise to the market, and under the former governor Kuroda. And the first episode was the introduction of QQE in April 2013, and the second one was expansion of QQE in October 2014, and the third one was introduction of negative interest rate in January 2016. And my question is I was wondering if your nonlinear VAR model can be used to evaluate each episode of this monetary policy. And of course, you can look at the shape of the impulse response function for each episode, but you can also do some sort of counterfactual analysis to evaluate what if the size of the shock were different or the timing was different. And in your case, you estimated this model using quarterly data, but I think you can do it using monthly data and do such an exercise. Thank you.
Ichiue?
Thank you very much for very interesting presentation. My question is about the assumption of the level of effective lower bound. Do you have to assume the level of effective lower bound before estimating VAR? If so, what's your assumption? 0%, 0.1% or minus 0.1%. And did you check the robustness to changing this assumption? I'm asking this because when I work a lot on shadow rate model using yield curve data, I often find that the results are not robust to changing this assumption. Thank you very much.
There are some a little bit more questions, but I don't like to erase the break time this time. So let me ask Professor Mavroeidis to respond.
I probably have the most difficult surname to pronounce in here. Thank you for those questions. On the lower bound for long yields, no, we haven't imposed a lower bound or allowed for a lower bound on long yields in this analysis, but this was limited by the methodology that I had developed at the time, but now I can, so we can definitely go back and revisit those things and see. The question would be what to set that lower bound to. There's a lot more sort of consensus about the lower bound for short rates, although there are some questions here about it, than for longer yields. Is the same model capable of capturing two different episodes of Japanese unconventional monetary policy? Here we have assumed the same model, but we don't need to. We can allow for time variation. This is certainly something that we can easily do, even with the existing methodology for that paper, but we haven't done it. Thank you. Moto's question on the different episodes, whether we can evaluate them separately. Again, that relates to the previous question. We can allow for time variation in the effectiveness of QE for the different episodes, and we can certainly do policy counterfactuals, very easily like in a standard VAR. It's just that there will be state dependent, of course, and we can certainly apply this to monthly data. And the final question on the assumption of the level of the effective lower bound. For the US, we used what most people do, which is 25 basis points. I think Woodford first started by arguing that anything below 50 basis points was the effective lower bound. But we've checked robustness to 20 basis points, say. In Japan, we used exactly the same approach as in the paper by Hayashi and Koeda, which is, I think, a very influential paper, where they used the interest on reserves plus 7 basis points. Now, you can play around with this a little bit, and that will mean that certain periods can be in and out of the lower bound, and that may have a little impact on the results, but not a lot in our experience. If you consider one period to be in or out of the lower bound. Yes, but we do need to assume that we know the lower bound. So alternatively, you need to know when the different episodes of ELB happened. You don't need to specify a lower bound. You can say these particular years have been, monetary policy, the short-term interest rate has been constrained, and the other periods have not been constrained. This is more difficult to relax in the existing framework. Thank you.
Okay, thank you very much, Professor Mavroeidis and Dr. Ikeda. I should have recognized him earlier, and their co-authors for the excellent paper, and Dr. Segendorf for excellent comments. And this concludes session 3, and we have a break.